I'm making a video. We are graphing rational functions. So in order to do that, you have to have the parent function. So let's talk about that. So the parent function is y equals 1 over x. Ooh, I hit the water bottle. Awkward. So there's your parent function. You're going to use that to make a graph. So here's my graph. Look how cute it is. I know. We have fancy graph paper today. And then we have a cute little table like so. I'm going to do some negatives and some positives, obviously, because we want to kind of look at both sides of this. So, and I'm just going to substitute these in. So 1 over negative 3 would be negative 1/3. Negative 1/2. 1 over negative 1 is negative 1. 1 over 0, since you can't divide by 0, that's going to be undefined. Let's not do that, shall we? 1 over 1 is 1. 1 over 2, 1 over 3. So I'm going to come over here and graph those. So if you have like a grid, like it's a lot easier, but so right here where x equals 0, that's going to be undefined. So let's go ahead and put an asymptote there so we don't accidentally use it. X equals 0 is going to be a vertical asymptote, right? Because that's anything that happens on the y-axis. So I'm going to have a vertical asymptote at the line x equals 0, right? Because we can't divide by 0, so x equals 0 is going to be an asymptote. Then I will have the point 1, 1. So that's a really critical point, 1, 1. And this point right here is another critical point, negative 1, negative 1. And if you continue to graph all of these out, you'll see that it kind of like curves around like so. And this one's going to curve this way like so. And it's going to come right through those critical values right here. There's going to be another asymptote on this as well, and that's going to be right here where y equals 0, because obviously y is also never going to be 0. So let's write that in. There's going to be horizontal. Oops, I ran out of space. That says horizontal. Asymptote, and that's going to be at y equals 0. Here's why. Obviously, y is never going to be 0, because remember, for a fraction to be 0, right? So for a fraction to equal 0, you have to have 0 over a number. Yes, any number. So it could be 0 over 3, 0 over 5, 0 over 10 for that fraction to equal 0. Well, that's never going to happen, because in the rational function, the numerator is always 1. So we know that y will never equal 0. We also know that x will never be 0, because then our function would be undefined. So we have two asymptotes, a horizontal asymptote and a vertical asymptote. Okay? This parent function is going to be in quadrants 1 and 3. So don't forget your quadrants. This is quadrant 1, quadrant 2, quadrant 3, and this is going to be quadrant 4. Remember, it makes the letter C for Rene Descartes, because Descartes was his last name. Actually, it was, this is his name, if you really want to know. Rene Descartes. I know what it looks like it says in English. It's not how you pronounce it. In French, he was French. And maybe it had just the E on it, I think. Anyways, there's the letter C. There's his name right there. Anyway, so that is your parent function. Let's talk about the domain and range, since it has these asymptotes in it. It's going to have a really interesting domain and range. So the domain is really interesting. So remember, you go left to right. So I can use everything from the left right all the way up to the asymptote. And then I can use everything on the right starting from that asymptote over. So what we actually say for the domain, there's two ways to write it. You could say that I go negative all the way to 0, but don't actually use that, so parentheses. Then you would union that with what happens on the other side of the graph, which is 0 to positive infinity. I've also seen this written as all real numbers except 0. So I've seen this as well. Either one of those would be acceptable. The range is going to have that same issue, because what we have right here, it's called discontinuous. So my graph is continuous here in the negative, and then it also is continuous in the positive, but these two sections don't touch each other. So when I'm doing my range, I'm going to say it starts at negative infinity, goes to 0, then at 0, goes to positive infinity without using 0. So again, I have negative infinity to 0, and I would union that with 0 to positive infinity. You could also state that as all real numbers except 0. This is going to affect the end behavior as well, these asymptotes. So the end behavior is kind of what happens as we go left and as we go right. So as x approaches positive infinity, meaning as we go to the right, the y value gets closer and closer to 0. Doesn't actually get there, but it looks like it does. So we would say f of x approaches 0. And then as the x values go to negative infinity, which is going to happen right here, the y values also go to 0. Now they're approaching 0. Remember, they're not on 0. They're approaching 0. And so we have that cute little arrow meaning approaching. Now let's compare that to a transformation in the graph. So let's say I have g of x equals 4 over x, right? And we're going to graph it. So when you do this one, so this is going to be really interesting. You have right here this vertical stretch, this 4 on the top, and that is going to affect your table. So what I'm going to do, this vertical stretch, this is a vertical stretch right here, is I'm going to multiply all of these y's by 4. Or you could do it in your head, however you want to do it. You could just make a new table for it, that too. So let's say, I don't know, -2, -1, 0, 1, 2, because I want to use 2's because I have a 4 here. So 4 divided by -2 is -2. 4 divided by -1, undefined, obviously I can't divide by 0. 4 divided by 1, and 4 divided by 2. I can use those to sketch out my graph. So I still have an undefined here on my y-axis, so I know I'm still going to have this vertical asymptote right here. So I already know that, vertical asymptote at y equals 0. Y equals 0. Sorry. That's not right. At x equals 0, because I knew that was going to happen. I also know that y cannot be 0 because the numerator is not 0. So I also know that I'm going to have an asymptote here. So I'm also going to have a horizontal asymptote at y equals 0. And I can plot these points here. So I have -2, -2, it's going to be out here a little bit more. And I have 2, 2, 1, 2, 1, 2 here. And then it's still going to approach these asymptotes. So remember, the curves will reach out to those asymptotes. Whether they do a shallow reach or really steep reach, they're still reaching. So what we've done is taken, it's really interesting because we've taken these critical values here, which were at 1, 1, and -1, -1, and we've just kind of stretched them a little bit away from the origin, and now we're at 2, 2, and -2, -2. So you can see how that vertical stretch, what it's doing is it's just pulling these lines a little bit away from the origin because these curves are still going to reach out to their asymptotes. Notice it still left our function in quadrants 1 and 3. So that is also interesting. It did not change our domain or range. Notice that was not changed. So, or the end behavior also didn't change. So all of those are really interesting that a stretch does not necessarily change any of that information. It looks like all the stretch actually did was pull this critical value or the critical point away from the origin. Looks like the only change that a stretch actually made. Okay. Now you can actually change your asymptotes, so let's look at an example where the asymptotes do change. Okay. Let's go here. So let's say I'm going to graph g of x equals -4 over x plus 2 minus 1. Okay, now what this is going to do, this is going to be your left-right movement. This is going to be your up and down movement. So when you graph that, you'll see that change. So what you're going to see is this -1, that's going to take this, ooh, I lost my picture. There it goes. Okay, so this minus 1 is going to go up, not up. It's going to go down 1. And then this x plus 2 right here, it will go left 2. This negative, the negative right up here, that's also going to affect this. There's going to be a reflection, and you'll see that in the table, okay? And then, of course, we still have that stretch of 4. So when you make your table, and you can choose the points however you want to. I did mine -6, -3, 0, 2, and 6. Obviously, you can choose whatever x's you desire. And I just plugged these into the equation to find the information I needed. So when you plot all of this out, okay, you'll see some things. You'll see that your asymptote will go down 1. So you'll see that you have this right here. So this asymptote went down 1. So now we're at y equals -1. And then that's going to be your horizontal asymptote. Then we'll also, our vertical asymptote will move to the left 2. So 1, 2. There we go. And I will have a new vertical asymptote at x equals 2. And then I have some points to plot here. Whoa! So -6, 0, 1, 2, 3, 4, 5, 6. That's right, yes? No, it's not. That's not right. I feel like that's not right. Let me pause because I feel like my table's wrong. Hold on. I have -6, 0. I have -3 probably right here. And so what you can see from that is that our curve is going to be this way. And then over here, I'm going to have 6, -3 has 1, 2, 3, 4, 5, 6. So something like right here, I have 2, -2. There should be an asymptote at 2. I don't know what I'm doing. Hold on. Nope. That's left. Y'all, this is supposed to go left. This a right. Look. I wrote left, and then I moved my asymptote to the right. Frustration. Let me fix my graph. Okay, everybody. For all of you who saw that, and you just let that go, so sweet of you. Don't do that no more. Okay, so x, here's y. I should have that horizontal asymptote. That's still there. Right, horizontal asymptote at x equals -1. And there's one to the left right here at, at x equals -2. This is y equals, horizontals are y. Y equals -1. Vertical asymptote right here, and you're going to see this swoop over here, and then you're going to see one on this side as well. So once you actually, the table is right. I don't know what I was thinking when I drew the graph. So here we go. And you'll see, now what I wanted to show you is this reflection here, this negative in the front here. What that does is it moves quadrants. So now this is going to be in quadrant 2 and then in quadrant 4. So that was what I was trying to show you, is that when you put that negative in there, it switches the quadrants. So that was the purpose of this exercise. Now, sometimes they'll give you a rational function and you won't be able to see where to move everything. So let's say they give you one of these guys, 2x plus 1 over x minus 3. And it's not super easy to see where all the movements are. So that being the case, we can divide this out so that it's an easier function for us to deal with. So, because remember, fractions are division. So you could just divide it. So I have 2x plus 1 divided by x minus 3. And we've done a long division with polynomials before. So x goes into 2x 2 times. So I have 2 times x is 2x. 2 times -3 is -6. I want to subtract these, and my remainder is 7. So remember, the way we write our remainder is 7 over the divisor x minus 3. Now this actually makes this significantly easier to graph. I can see that I have a vertical stretch. I can see I should move to the right 3, and I should go up 2. So that being said, I can see the movements in my asymptotes. So when I'm sketching this, it's so much easier to sketch out. I can see that I'm going to go right 3, so 1, 2, 3, and I should have an asymptote here at x equals 3. Because obviously, if x is 3, then 3 minus 3 is 0, and I would be dividing by 0. So obviously I want an asymptote there because I want to keep from dividing by 0. That would be a very bad idea. Then I have this plus 2, so I'm going to go up 2. 1, 2. There we are, and I can see that I also have an asymptote here at y equals 2. This is positive, so I know it's going to be in 1 and 3, so I would sketch it here. And it's going to have a stretch, so remember, it's not going to be like, it's going to be like pulled away from the center of these asymptotes a little bit. So that just makes it easier to graph. Yeah. Okay. And that's the concept right there. Have fun.